Hello, my name is Laura, and this work was developed at the Chemistry Institute of the Federal University of Rio Grande do Sul. Enzymes are shown to be excellent catalysts, with a high conversion and an excellent enantiomer specificity and selectivity. Consequently, the industrial use of enzymes has grown greatly, being used as catalysts of diverse reactions such as esterification, transesterifications, and hydrolysis reactions. The immobilization of enzymes greatly increases stability, enabling their recovery and reuse, and eases the burden of enzyme cost. In this project, it was used a silica-based support which had a surface modification with an organosilica, which have an epoxy group as an organic linker that can act to enhance interactions between the pore walls and the enzyme, greatly affecting stability and recyclability of enzyme. The purpose of this work was synthesize a mesoporous silica with a surface modification to act as a support for lipase enzyme mobilization, and apply these heterogeneous biocatalysts in the production of flavoring esters. The silica-based support was obtained from the gelatin of a tetrathiorthosilicate with ethanol in acid pH. The support was functionalized with GPTMS using the apparatus for grafting reaction. The immobilization was performed using 3 different types of lipase enzymes. To obtain the heterogeneous biocatalysts, it was used 100 mg of the support for 5 mg per milliliter of an enzyme solution. The synthesized material was characterized by thermographic meta-analysis and textural analysis. This decreased the amount of adsorbed nitrogen, indicate that the silica surface was covered with the organosilica. The pore size distribution curve showed a maximum at 18 nanometers, classifying it as a mesoporous material. The material had a first loss of weight from the room temperature up to 115 degrees, that reportedly attributed to water disruption from the surface of the material, and the decrease between 150 to 650 degrees is attributed to the dehydroxylation of the silane groups. The model reaction of pyranitrophenol palmitate hydrolysis was employed to evaluate the enzymatic activity. Better results were obtained with the enzyme CalB, with an efficiency of 79% and recovery activity of 14%. These heterogeneous biocatalysts containing the immobilized CalB enzyme was applied in the esterification reaction, resulting in a 51% conversion after 3 hours of reaction. In this work, a hybrid material was synthesized, constituted from the functionalization of a sol-gel silica synthesized in the laboratory. The resulting material has a high specific area and pore size suitable to act as a support for lipase enzymes mobilization. The heterogeneous biocatalysts proved to be effective in the synthesis of flavoring ester.